Hello everyone, in today's video we're going to set up a home radio station using this peculiar but effective antenna, a USB receiver and one of my usual friends, the Raspberry Pi 4. Yeah, so first of all let me show you the antenna. So this antenna looks like a normal monopole with some additional elements. So yeah, let's start with the idea of a monopole with omnidirectional coverage. This is called a discone, not a monopole. It is a monopole with these elements making a disc. It could be a flat disc, but it is a radial disc in this case. And these elements shaping a cone. There is also a coil here to adjust the impedance. So, part of the elements, let me check it out. The disc acts as a capacitive element and the cone as an inductive element. So, this antenna is very well adjusted to work in a wide range of frequencies. Let me show you the manual. Well, not a manual, but just an instruction sheet, okay? So, as you can see here, this antenna is very good for receiving from 100 to 1500 MHz. And it is also suitable for transmissions. It can transmit in these narrow frequencies. These 144, 430, 900 MHz, well, these are the usual frequencies used for transmission in hand radio systems, like, well, low power device, public mobile radio, and so on and so forth. So, I just have to adjust the nuts. I don't have spanners. It would be better with spanners. I have this big monkey wrench, and let me set it up before continuing. I'm already having a bad time here because I broke one of the elements. It is loose because it is broken in the inside. Well, so I have fastened the bolts in the brackets, in the U-shaped brackets, and this tube comes with antenna, and it helps you set up the cable. You have to watch this. You have to pass the cable with the connector through the tube like this, and then you get the main connector. You put the antenna, you plug it. Okay, and there is a tiny screw here that fits everything together, the tube and the antenna. So first you take it off. Oops. Oh, there it goes. Well, and then you put it like this with the gap. There's a tiny gap here, so you can put the screw back again and everything will stay firm. So nice, everything's okay now. I fastened this screw so the antenna is attached to the tube. The tube is attached to this other L-shaped tube that is going to be outside, and with the help of these U brackets everything will be firm and sturdy. I forgot to mention one thing before. It's about the frequencies. This antenna is suitable for receiving in every frequency from 100 to 1500 but it is only suitable for transmission in certain frequencies. If you try to transmit in any other frequency, you can destroy the antenna due to the standing wave ratio, which is the quotient between the impedance of the antenna and the impedance of reference, in this case 50 ohms. If you do not respect that, you may destroy your transmitter or the antenna or both, okay? Yeah, so there is the antenna. So now I have to pick up the original cable and cut this connector before letting the cable go through the hole in the wall. Look at the mess I made. They said 4 cables were too much for a 20 centimeter tube, but what are they going to say now? Yeah, well, let's get all this together. Now the cables are all in the inside of the house, so I can close the window. This is a warm October, but it gets chilly at this time of the night. Okay, the cover goes here and everything will go inside, perfectly wrapped inside this cable organizer. Look at this. The sockets, the blind covers with a tiny gap, the cable organizer. I say this is going to be wife approved, 100% sure. The cable is inside and the antenna is outside, as I wanted. But in the process I had to cut the original connector. So what I'm going to do is I'm going to take this pigtail adapter off and I'm going to connect with an SMA connector. So if I do this, I'm not going to need any other adapters. So first we start with a clean cut and then I peel the jacket off. You should do it in a single turn, but it is not that easy. So you pick up the cylinder, the metal cylinder, and you put it on before doing anything else. Okay, now you have to measure the distance. Yes, this should be okay. And then remove part of the metal shield. And peel off the dielectric. Okay, ready. So now you measure again. Okay, this could be too much. This looks better. Too much live connector here. And too much shield. Okay, nice. So, what we do now is, oh, I can't pick it up. Okay, we pick this connector up and we add a little bit of solder. Okay, so with the melted tin, this will stay together forever. Okay, so now it is better. I'm going to put the male pin here. Now the outer connector. Okay, and now I have to trim a little bit of the shield. A little bit more. And you can see how the cylinder is going to cover everything. Okay, so now I have here my crimping tool. You put it in the proper place and there you go. And you release. The connector is properly crimped. Nice. So you can put it here and now you can connect it to your computer and start receiving and, if you want, sending signals. But we don't stop here. We're going to set up the server to allow everyone in the network to access the software-defined radio. Very well, now in this part of this video I'm going to connect this Raspberry Pi to the software-defined radio receiver, then to the network here, to my desktop switch, and then I'm going to power it on with the power supply. Okay. Time for some keyboard. So, as you can see here, I have been pinging the Raspberry Pi for some time and it is replying. So, I can stop the ping and try to log into it using the secure shell protocol. The password, and now we are in. So first things first, with list USB you can list all USB peripherals, and here it is, the SDR, the receiver. Okay, so now with RTL-TCP we're going to set up a server available in all possible addresses and run it as a service. So it is connected. And now I'm going to open an SDR receiver application. Okay, and here you have the list of possible sources. This is the USB version and this is the network version. So you just have to type the address on the port. This is the default port and you can start receiving. Yes. To sum up, with software-defined radio you can receive a lot of signals and demodulate them. You have the typical broadcast FM, you can detect the Morse code in the airwaves, and you can have a receiver that supports many amateur signals, and you can, well, listen to them if they are not encrypted, which may be the case if you try to decode police signals, but, well, the possibilities are infinite.